Okay, today we are going to talk about translations. And your eyes are up here. Translations in the coordinate plane. This begins on page 522. Translations are a type of transformation. Transformations. This is in the video that we can't see, but it'll be on the video. Transformations. Who's had a transformer? Who has? Who owns one? Poor you pitiful people who don't. About two-thirds of the class, three-fourths of the class has transformers at home. This is one of mine. I've got another over here. This is just like a baby transformer over here. Okay. But today, transformations are just making some sort of a what? Change, some sort of a change, okay? And today's change is ever so small, actually. It's an operation that can change a figure. So we're doing something mathematically to change the figure. And today's change is simply taking your figure, so here's a figure, three-dimensional, and this is the kind of change today. Everybody's eyes here? The kind of change today is simply this. Now, is the size different if I do that? No, it's just where it is a little different on the page, okay? This is in space because I'm three dimensions here, so we could still call it the same thing. It is known as, does anybody know the name when you just move it? And here's a hint for you. It looks
a slide
like that. It looks like a slide, but it's not called a slide, it's called a somebody said it. Good. Translation. Notice in the word translation, you have SL, like a slide. You can see it. So here I'm going to translate the figure down the slide, and the poor figure has no face. I left the face up there. I think if I grab the whole thing, I can slide it down. There we go. Okay. So it's simply not rotating, it's not reflecting, it's just moving. Maybe we could say down and over, right? That's what we're going to see mathematically speaking. So a type of transformation known as a slide. Each point moves the same distance in the same direction. So for instance, we have a lot of points on this figure when we move it, but what are the key points that we would move if we're moving a figure from one place to another? There are key points on a figure. Lauren?
The vertices.
Good, the vertices, or like a third grader would call them the corners, right? The vertices. Okay, we simply have 2 pages left of these notes, but there's a lot going on. The first one, we're going to say, if you receive a picture like this, a graph, and you see that some polygon has been moved, translated, can you explain how that polygon was translated? How did that triangle go from this location here to the new location there? Okay, and there's some terms that we need to understand. So first of all, let's talk about labeling transformations. The original is just labeled with letters, as we have been doing already, right? The image is the new figure after it's been moved. Okay, so that's what the word image means. New figure. And notice the difference in the picture. It has the same letters, but what did they add? What's been added? A little apostrophe. And so they call that A prime. So it means it's not the first A. Here's A. But there's like a second A. It's like the first, but it's in a new place. So A prime. Okay? It's been moved. And notice all the letters have been moved and they all have a little prime mark. Okay? So we're going to identify where the original point was or is. So here's point A, and where the image of that point is. We're going to write this information down so that we can figure out what math was done to move it, which is the goal. What math was done. So I'm going to give you the original point. There you go. And you may need to pause the video and take some of this down, but see if you can tell us where the image of the original has moved. Okay, so who can tell us where A prime now is? All you have to do is give me the X and Y coordinates for A prime. Can you tell us, Faith? 1, 2, 3, and then
Oh,
here.
3. I was looking at where it was. 3.
Walk 3 and fly
Oh,
1. Good job.
sorry, I was thinking.
Understand what we're looking at now? It's this point over here that is the new location for the copy of A, but it has been moved, right? It's an image. How about B? Who can give us the coordinates for B? Liam, can you do that? Where is it? B prime. Very good. So it's at 5, -2. And C prime. Can you give us those coordinates, Courtney? Can you see it? It's just this here. So we're going to start at 0, 0. And how far do we walk?
3.
1. Walk 3. Do you see it's right here?
Oh, 2, 1.
Walk 1 and fly.
Down.
Go down how far? 2. So 1 and -2. 1 and -2. Okay, so as I said, the goal now is to create the rule for this. How did these vertices move? So we're looking at the original and what happened to get it to this. So we're doing what we call a map. Here's the original. The original was at XY, right? Now let's just look at the X's and see what happened to all the X's. This X here went from -4 to what? 3. So on a number line, if you're going from -4 to 3, how far have you traveled? 7. You went +7, right? Let's see if that's the same for B. B went from -2 to what? 5. And so is that also +7? Good. So it looks like it's just add 7. Add 7 to your which letter? X, right? Let's see if it's true for C. -6 plus 7, is that 1? -6 plus 7 is. Good. So we can write that rule as X plus 7. Okay? The second value in the parentheses, the Y coordinate, right? We're going to check that out. Let's start with A again. Going from 6 to 1, what have you done? Subtracted 5, I hear. Okay. Is that the same if I go from 3 to -2? Is that -5? Okay, and how about 3 to -2 here? That's the same exact value. So yes, -5. So who can write the rule for this? It would be, Riley?
X plus 7, and then X. Y is X.
Y
Y minus 5.
-5. We don't use X, we use Y now. Y -5. So we're saying, this is our sentence, our math sentence that says the original point XY goes to X plus 7 and Y minus 5. All of the points in this original triangle have moved that far. Okay? So what happens, let's think about what happens with just the X values. When you add to the X values, which way do they move? Do they move to the left or to the right? To the right. Now what if I subtract from the X? Which way will I move? Left. So we can put that down here in a little, side note. If you want to slide right, add to your X. If you want to slide left, subtract from your X. Do you understand how we got that? Okay? And then what about going up and down? What value are we changing if we're going up and down? The Y value, right? So what will we do to the Y if we want to move up? Add. But in this case, we subtracted, so instead of moving up, this figure moved down, right? As a matter of fact, this figure moved to the right and down. It's a combination, isn't it? Okay? So you might receive a graph and you're asked to map it like this. Simply label all the points and see how X has changed, see how Y has changed. Okay? The other way you might receive this question is, here's a figure. Now we're going to give you a rule and you move it. Okay? So this figure is here. RSTU has vertices given here. Translate it. Given this rule, XY becomes X plus 3 and Y plus 4. So does anyone have an idea? How might we show the work here so that we can get this job done? How do you do this? Any ideas, Nicholas?
Would you add to each coordinate to x plus, like, for r, that -7.
Good. So he's saying, go ahead and write where the new point is, right? And so this -7 has -7. We're going to add 3 to it, and you end up with -4. And what are you going to do to the -2? Add 4, and you get 2. Okay, so if you haven't already, that's what you're doing. So make sure you find these coordinates and then come back and check, right? So there you go. We have added 3 to every x, and we have, in this case, added 4 to every y. So we can plot these. Don't forget to start at 0, 0, right? -4, 2 is r prime. -1, 1 is s prime. -1, -1 is t prime. And -4, 1, 2, 3, 4, -1 is u prime. And so to finish it, what would you do? Draw the segments, right, between them. Because the vertices moved, right? But of course, all the points in between the vertices moved these same distances. If you wanted, you could do that mathematically, but I'm sure nobody wants to do that mathematically. It's a lot of work. So we focus on the vertices. Give the vertices of the image the new mapping, and then graph that. And there you go. Have we the same, do we have a congruent polygon here, or do we have a similar? Is it just similar, or is it totally congruent? Who says similar? Just similar. Who says totally congruent? Good. So notice translations, when you slide a figure, like when I move this one here, does it change the size? No. Same size, same shape. It is simply in a new place. And there you go.